Lesson 70, solve direct variation problems. So this is a review of what we went through in our last lesson. Remember, direct variation is y equals kx. And so we're going to use that formula to solve some word problems. First one, the amount Ellen charges for banquet food varies directly as the number of people that attend. If Ellen charges $780 for 60 people, how much does she charge for 100 people? So to set this up, we need to find the constant. So if the constant equals, first off, let's go y equals kx. A y is like the charges, and the number of people is like your x. So now if I have, we'll use charges is the same as the constant times the number of people. So I'm going to use p for people. So if I want to solve for the constant, I divide by p on both sides. And so when I'm going from one situation to the other, the constant stays the same. So it's charges to people. It's the same as charges to people. So if I set up a ratio here, I would have $780 to 60 people is the same as charges for 100 people. Now I can cross multiply. So 780 times 100 would give us 78,000 equals 60 times c, so 60c. Get c by itself, I divide by 60. So 78,000 divided by 60. You would get the charges would be $1,300. That would be the cost for 100 people. The next one, driving at a constant speed, the distance Maggie travels varies directly with the amount of time she travels, or she drives. So distance is like your y, time is like your x. So distance equals the constant times the time, which would make sense because the constant is your rate. Rate times time equals distance. So if Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? So again, to solve for constant, I divide by t on both sides. So it's distance divided by time. It's the same as distance divided by time. For distance, 75 miles for 1.5 hours. So 1.5 hours is the same as 100 miles in how much time? So here, cross multiply. So 1.5 times 100 gives us 150 equals 75t. Divide by 75 to get t by itself. So 150 divided by 75, t would give us 2. It would be 2 hours to drive 100 miles. Next one, the distance of coiled spring stretches varies directly with the amount of weight hanging on the spring. So distance, y, amount of weight, your x. So we would have d equals kw. If a spring stretches 2 centimeters when a 30-gram weight is hung from it, how far will it stretch when a 75-gram weight is hung from the spring? So distance divided by the weight equals the distance divided by the weight. So the distance is 2 centimeters. The weight of 30 grams is the same as how far distance when you have a 75-gram weight. Cross multiply. 2 times 75 gives us 150 equals 30d. Divide by 30 on both sides. The distance would be 5 centimeters. On the second one on here, the number of words Tom types varies directly. So the words would be our y, directly with the amount of time. T would be our x he spends typing. So if Tom types 100 words in 2.5 minutes, how many words does he type in 15 minutes? So y divided by x, so words divided by time equals words divided by time. Words, 100, 2.5 minutes. It's the same as how many words in 15 minutes. Here cross multiply, so that's 1500 equals 2.5 w. Get w by itself divided by 2.5. So 1500 divided by 2.5. The number of words would be 600. And our last two problems. There were 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18 people waiting in front of Delia. Predict how much longer Delia will wait to be helped. So to solve this one, there were 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18. So if I subtract 23 and 18, that means 5 people were served in 3 minutes. So if I take the time divided by the number of people, time divided by the number of people would be 3 minutes for 5 people. 3 divided by 5 is 0.6. So if I take 0.6 times 18 people, how much longer will she have to wait? So 0.6 times 18 gives us 10.8. So we would say roughly 11 minutes. And the last one, traffic was dense for the evening commute. Mitchell traveled 3 miles on the highway in 15 minutes. Predict how much longer it will take Mitchell to reach his exit 5 miles away. So to find the speed would be distance divided by time. So 3 divided by 15. 3 divided by 15 would give us 0.2. So rate times time equals the distance. The rate we said was 0.2. We need to find the time, and the distance is 5 miles. So if I divide by 0.2, 5 divided by 0.2, time would be 25 minutes. That is our lesson today on solving using direct variation.